First, let me go ahead and give you a little bit of background on myself. As it says up there, I'm the chair of the science department at San Diego Christian College. San Diego Christian College, for those of you that haven't heard of us, we are a small liberal arts undergraduate institution out in Santee. Our beginnings were with Drs. Tim LaHaye, Henry Morris, and Art Peters. So founded in that creation mindset, Henry Morris of Institute for Creation Research. So that just kind of gives you an idea of where I'm coming from. I did my undergraduate studies in biochemistry at Biola University, and then went on to graduate studies at San Diego State, a PhD program in cell and molecular biology. That didn't turn out so well. I didn't actually finish it. I'm not actually Dr. Hilliker, sorry. But that's, Mr. Hilliker, Professor Hilliker, that's what I tell my students. But you can call me David, because that's all right. But I did end up getting a master's degree from Institute for Creation Research when they were still here in California, in Santee, actually. So that's my background as far as education is concerned. I was brought up in a Christian home and have accepted Christ when I was 5 years old. So I've grown up in this. I have been a creationist, maybe longer than I've been a Christian. I didn't know any different. But I started getting interested in the idea of creation and a young earth creation specifically. When I was about 11 or 12 years old, I started reading some books, and I was mentioning to Dave that I've been teaching in some form or another on the subject of origins since I was about 12 or 13 years old. My youth pastor asked me to do a youth group one evening on origins, and that's where it started. But I've been teaching at San Diego Christian for 16 years now. And one of the classes that I teach is called Scientific Models of Origins. And I'm going to take you on a whirlwind tour of that class, that 15-week course, in 1 hour. Okay. I'm not going to try and teach you everything that's in there, but we're going to get a little smattering of things from all over. You go ahead and go on the next slide there. This is where I want to start. Why does it even matter? Does it matter that it's a young earth or an old earth or evolution or creation? I'm going to focus on that first one, the young earth versus old earth today, and that evolution and creation kind of goes along with that. But I felt that for this morning it would be more important to take a look at that young versus old earth, because that's part of the heart of the question. And as it says up here, many will take the view, particularly old earthers, will say, well, the Bible tells us who created, and maybe it'll tell us about what he created and why he created, but it doesn't really tell us when and how. I don't know. If you go on the next one, it seems to me that if you read through chapter 1 and 2 of Genesis, where the creation account is, most of it seems to be about when and how. I don't know, day 1, day 2. It kind of gives you that when and how. And if you look at the rest of the Bible, go ahead and go on to the next slide there. And I don't remember if I put this as, I did. Okay. Go ahead and just click through until you get to, there's a picture at the end, and don't go past that one. Okay. I put this together and stepped through it. I'm just going to put them all up there at the beginning. If you look at some of these, just some major areas of conflict between creation and evolution, and between a young earth and an old earth. Well, really, between an old earth and the Bible. And the first one that I said there is the age of pretty much everything. If you have probably read and heard and been taught a lot of things about how the dinosaurs died out 65 million years ago, and so that one doesn't jive with the young earth. Or that man evolved from most recent common ancestor, the Australopithecines or something like that, about somewhere between 1 and 3 million years ago, depending on where you put the dividing line, and so on and so on. And so these ages of all these different things, and how long it took for Pangaea to split up and become the continents that they are, I believe it's something like 600 million years. Anyway, all of those. That's a major point of conflict. And the reason I'm bringing all these up is just to show you, as it said on the first slide, what does it matter, right? Death before sin. That to me is a huge one. If you have evolution, if you have an old earth, and things living on it before Adam comes along, then that thread that goes through the Bible of the idea that it's because of sin that death came into the world. Death, the wages of sin is death. Now, specifically that's talking about us, and it's talking about spiritual death, but it's also talking about physical death. And there isn't a distinction as much between those two, especially when you look at Genesis chapter 3 and the story of how sin entered the world. It's very clear as you read through that this is something bigger than, not that spiritual death isn't big, but it's something bigger than that. It's something that touches the entire animal kingdom. And let's see, what else do we have? Man is a special creation versus the involved animal. I don't think I need to say much more than that on that one. That one's explaining itself. Genesis 1, that's the story of creation. Okay, so there's definitely a big discrepancy there, especially when you compare the order of creation and the order of evolution. There are several things that are just flipped, that are mixed up, that are out of order. Exodus 20, verses 9 through 11, that's the Sabbath command. God commands the people of Israel to work on 6 days and rest on the seventh. And the reason that's given is because that's the way God created. He worked on 6 days and rested on the seventh. That says it to me that God actually worked on 6 days and rested on the seventh. It wasn't some long period of time over which creation unfolded. Psalm 29, 10, 33, 9, those other references there, all of these are references in the Psalms where it speaks of creation or the flood, and it speaks of it as historical events. It testifies that the psalmist, whether David or one of the other psalm writers, viewed the global flood of Noah's day and the 6 days of creation as literal historical events. And in fact, in some of these, they're alongside things like the Exodus or God's deliverance of the people of Israel from the oppressors that were there in the time of the judges. Isaiah 54:9. This one, I've got notes on each of these, and this one just says, read this one. So, I'm going to pull this up, because you don't get the flavor of it unless it's read, and hopefully my Bible will come up here. It's taking a little while. Oh, there we go. Isaiah 54, verse 9, is talking about Noah's flood. And it's similar to those Psalm passages in that it's treating it as a historical event. But it's important to recognize that it's God talking here. And that God is talking to the Israelites who are being punished right now because they've gone off, they've done idolatry and just some really horrible things if you read some of Kings and Chronicles. Wow, it's amazing. But this is God saying to the Israelites, I'm not going to be angry with you forever. Listen to what he says. For this is as the waters of Noah unto me. For as I have sworn that the waters of Noah shall no more go over the earth, so I have sworn that I will not be angry with thee, nor rebuke thee. I took, as it says, I took a lot of these references from Answers in Genesis book called the New Answers book, and in that chapter where it gives this reference and some others, it says that a promise like this, if Noah's flood and the 6-day creation are just allegories or mythical events, this promise becomes something like As Santa gets in his sleigh every Christmas Eve and delivers presents to all the good boys and girls of the world, so I will not be angry with you forever. Doesn't quite have the same impact, does it? We have to view these as real, literal events because some of God's promises. When Jesus says about, as it was in the days of Noah, so it will be at my return. Doesn't have the same impact if the days of Noah wasn't really what Genesis chapters 7 through 9 says it was. Okay, moving on to, I don't want to go through all of these, but just let me quickly address some of them. Ezekiel, that verse, or those verses, continually refer to Daniel, Noah, and Job. 3 real people. And so again, if Noah was mythical, then Daniel was mythical. I mean, he's being paired. All right. Luke 3. That's the genealogy of Jesus. Oh, I just noticed I skipped one. 1 Chronicles chapter 1. It's another genealogy. Both of these genealogies, the one in Luke, the one in Chronicles, go from Adam all the way up to the present day of the writing. And both of them match the genealogies that are in Genesis 5 and 11. And that's where young earth creationists get the idea, those genealogies in chapters 5 and 11, and from the creation account, that the earth is thousands of years old, not billions of years old. Okay, so then 1 Peter, basically these are references to the flood, to Noah, and to creation as historical, testifying that Peter believes that those were historical events and believes in a young earth. The passages there from Romans and Corinthians and Timothy testify that Paul viewed these things as real events that happened. And then the passages from Matthew, Mark, and Luke, these are Jesus speaking, where he affirms a young earth creation. And he ought to know. As mentioned before, it is by him and for him that all things were created. Okay, let me go ahead and move on. I'm going to address over the next few, several slides, at the majority of the time here, I'm going to look at 3 of the main objections to a young earth from a scientific standpoint. You could say arguments against a young earth or evidences for an old earth, whichever way you want to look at it. That's where I'm going to spend a lot of the time, the rest of this time. All right, so one of them is radiometric data. Okay? Another one is astronomy, distant starlight. How does the light from distant stars reach us if the universe is only thousands of years old? And then the third one is the fossil record. So we're going to look at those 3 in a bit of depth. We're going to take a look at some other evidences of the age of the earth on the other side, evidences for a young earth, and then we'll wrap it up. Okay, hang on to your hats. I know I've been talking pretty quickly so far, it's going to get faster. So go ahead and just go through, a few of them, 3, 4 clicks, something like that. So radioactivity, how many of you would consider yourself scientists? Okay, I will go through this then. So most of you probably know a little bit about radioactivity, how it works. But as it says up there, there are some elements that are stable, other elements decay. We call those radioactive. Okay? And they decay at a particular rate. Okay? And based on that rate, there's a lot of things, a lot of fun things we can do with radioactive elements. Okay? One is we can trace where they are. We can detect them based on their radioactivity. So we use that in the medical profession. We use that in other areas to see where the things go and what different molecules do that we attach that radioactivity to. But also it allows us to tell how old something is that has that element in it, or how long a sample of that radioactive element has been sitting there, decaying. Okay? As long as we know some things about it, there's some assumptions that go with that method. And we're going to get to that on the next slide. I just give you a few examples here of some of these elements. Carbon-14, half-life of 5,730, and yeah, go ahead, a couple more clicks. Yeah, okay, good. So radiometric dating. How does it work? Well, since these elements decay at a specific rate, all we have to do is know how much there was to begin with, how much there is now, and what was the rate at which it decayed, and then we can figure out the time between its beginning and now. Okay? That's the theory. There's assumptions. One is that in this rock that we're trying to date, and that's what we're usually looking at, is rocks, with one exception. Carbon-14 dating is typically looking at something that was once alive. We'll talk about that one a little bit later. But so you've got this rock, and we want to know, when did this rock form? Well, we assume that in the history of the rock, there hasn't been any of the element, whether the parent element or the daughter element, the one that is decaying or the one that is decaying into, hasn't gotten into the rock or leaked out of the rock in the entire history of the rock. Okay? So that's an assumption. Second assumption is that, I just want to make sure I get them in the right order. The second is that the rate of decay has been constant throughout the history of the rock. And then the third one is that it started off with none of the daughter element, the one that is being decayed into. Okay? That it starts off with none of that at the beginning. Now there are some methods that will help us out with those assumptions and essentially get rid of that third assumption. The second one never goes away. And so if there's been a change in the rate of decay over any time, we don't know. We can't, well, I'm going to suggest that we might have some clues that it has changed. Okay, so let's go on to the next slide, just to look at how well does this work. Okay. I'll let you read through those quickly. These are potassium-argon dates and actual dates of lava flows from around the world. You can see they don't agree. Okay. That's the bottom line here. And I would extend that to any time that any rock has been, that we know when it formed, has been dated using radiometric methods, it's got the wrong answer. Now, for those of you who would consider yourselves scientists out there, those of you that don't, you can join in as well. If you're going to have a method to determine pretty much anything, you want to test it first on something that you know and see how well it measures, right? This one fails. Go ahead and click one more time. You can't see this very well, but up there is another illustration of how this does not work very well. They took the same rock and used different radiometric methods, different isotopes that they measured, and got different answers. Sometimes the variation is as much as 50% of one of the agents or more. In fact, there was one that was measured as 550 million years by one method and 1.5 billion years by another. Okay, that just doesn't work. All right, go ahead and go on one more. So what you see up there are, on the left-hand side, you have zircon crystals. These are found in granitic rocks, and they're kind of interesting in that zircons will hold on to uranium. They actually kind of attract uranium as the rock forms. And uranium is one of those radioactive elements, and it decays, and as it decays, it releases alpha particles. And alpha particles are essentially a nucleus of a helium atom, essentially. They are the nucleus of a helium atom. And so, after the decay has occurred and these alpha particles are released, they go out and they're sitting there in the zircon crystal, and they grab onto some electrons and become helium. Now, if you know a little bit of chemistry, you know that helium doesn't interact with anything. It's a noble gas, right? It doesn't form any compounds. It just exists as helium atoms. It's also very small, and because it's very small, it travels really well. It leaks quickly, okay? And so it leaks out of these zircon crystals too. On the right-hand side, what's up there is a little graph that shows measurements of the helium leak rate out of these crystals at various temperatures that they measured it. And they took an old Earth assumption and said, okay, this is what we should see. Took a young Earth assumption and said, this is what we should see. The old Earth assumption is down here. The young Earth assumption is down here. The actual data is over here and lines right up with the 6,000-year-old assumptions. Something weird is going on. Okay? There's too much helium left in these zircon crystals for the amount of time that the radioactive decay says has happened. That's what I'm suggesting is evidence of accelerated radioactive decay at some point in Earth's past. I don't know exactly when it happened. Probably creation week. But we don't know that because the data doesn't tell us that. But it does tell us that something weird is going on and that there is a discrepancy between the helium leak and the uranium decay. Okay, let's move on to radiocarbon dating. This is one of the most popularly cited evidences against a young Earth, which is kind of weird because radiocarbon dating can't date anything back further than about 100,000 years. So it's fine to say you can't have your 6,000 to 10,000 year old Earth based on radiocarbon dating. Even that is questionable though because of what we've seen before. But it doesn't say millions of years. It at most says thousands of years, tens of thousands of years. In fact, the oldest radiocarbon date that I've seen says somewhere around 60 or 70,000. Okay? The 100,000 is the limit of the detection of that carbon-14. So, go ahead and click a few more. Oh, there we go. One more. Okay. So that pen in the center picture is pointing to something that the other two pictures are illustrating. Okay? So it's pointing to a little round fossil. Okay? That little round fossil is one of these guys that's on the left, but you're looking at him down, is the cone-shaped shell. Okay? So it's a cross-section of that. That guy is called a belemnite. Anybody ever heard of a belemnite before? That's okay, because until I'd seen this picture, I hadn't either. So on the right-hand side, you have just a bunch of different types of belemnites. There evidently were a whole bunch of these squid-like guys in the fossil record, and I have no idea. But they are used as something called an index fossil. An index fossil is how you tell how old the fossils in rocks are. Okay? You dig up a bunch of fossils in this one set of rocks, and among them you find an index fossil. That index fossil is only found in a certain type of rock. Okay? And because it's only found in a certain type of rock at a certain age according to evolution, then anytime any fossils that you find in that rock, and anytime you find that index fossil in a rock, that rock and all the fossils in it must be that same age. So this particular belemnite that the pen is pointing to is an index fossil for about 189 million years old fossils. Okay? Now, I don't know how well you can see it, but right above that belemnite fossil is a fossil that's kind of long and going across the rock there? It's a piece of wood. Okay. Belemnite is like a squid. It's of the same type of family. So where does a belemnite live? In the ocean. Good. All right. Where does a tree grow? Not in the ocean. On the land, yes. Okay. Why is there a squid and a tree branch buried in the same rock? The flood. Absolutely. So this fossil right there shows the flood, I think. But it actually shows something even more than that. I said I was going to be focusing on young Earth versus old Earth. I got off track a little bit there, but we're coming back on. Because that's an index fossil for 189 million years old. The wood was carbon dated. And that right there tells you there's a discrepancy because you can't carbon date something that's older than 100,000 years. It was carbon dated as 23,000 years old. That's a little different than 189 million. Now, I don't believe that the wood is 23,000 years old, but it definitely shows that there's a flaw in the dating method. Okay, let's move on. Go ahead and click a couple more here. One more. There we go. So radiocarbon actually is accurate. Radiocarbon dating has been shown to be accurate up to about 2,500 years into the past. Okay? It's really good for dating archaeological stuff, historical artifacts, things like that. Okay? There are some exceptions, as noted there. Go ahead and put one more. What happens in these cases, we've cross-checked it with like tree rings or other dating methods that we know are really reliable. Like it was sitting right next to a historical document that gave us some reference to a king that we know when he was around, those kinds of things. So we know that those dates are accurate. Once you get beyond that, it doesn't work. And I think this is very likely due to the fact that radiocarbon dating is based on the ratio of carbon-14 to carbon-12 that's in the current atmosphere. And it makes the assumption that at the time when the thing died, because it's got to be something that was once alive, when the thing died, the ratio was the same as it is now. But we actually know that that's not the case. The ratio is still changing. Evolutionists will point out, well, that's the reason that it's changing now and hasn't actually come to equilibrium yet is because of the Industrial Revolution. We've been burning so much coal and oil and all that kind of thing and spewing carbon into the atmosphere, and it's knocked off the balance, and so that's why we have to get back to equilibrium. They have to say that because it only takes about 30,000 years for radiocarbon to come to equilibrium. So they've got to have an excuse, otherwise the Earth is less than 30,000 years old. I find it interesting that that's their excuse. It doesn't match up with the fact that radiocarbon dates work back to about 2,500 years old. So, moving on. I'm going to go to the next topic. Go ahead and click over here. Looking at distant starlight, give it about 5 clicks. I use some of these slides in my class at various points, and I bring them in. I like to keep them in suspense. Anyway, distant starlight. This is an issue for young Earth creationists, or it has been from time to time, because it seems like it's proof positive that the universe is billions of years old. There's stars all the way out there, billions of light years away. Now, I should point out that a light year is a distance, not a time measurement. Okay? So just the fact that there are stars out there billions of light years away doesn't mean the universe is billions of years old. What an evolutionist will point out is that the fact that we can see those stars means that it's billions of years old, because the light has to have traveled that distance. And a light year is the amount of distance that light can travel in 1 year. So it's just like if we said a car hour is 60 miles. something like that. And it doesn't really work that way with traffic and all that. But that's kind of the correlation. All right. So if there's these stars out there and we can see them, how is it that we can see them if the universe is only thousands of years old? So several theories have been proposed. We're going to take a look at 5. And some of them we're going to look at really quickly. So go ahead and there's 4 lines on there. Go ahead and put them all in. One is, maybe the universe isn't as big as they think it is. I mean, how do you measure distances that large anyway? There are a couple of methods. One of them only works out to in the hundreds of thousands of light years, and that's a method based on trigonometry and looking at the star at different points in the year and measuring angles and calculating, okay, based on that, how far is it? It's a very accurate method, but the angle gets too small at some point to where you can't distinguish it exactly, and yeah, so you lose it. The other method that's used is something called Hubble's law. It's a relationship between how fast stars are moving away from us to the distance that they are currently away from us. Okay? That's the idea. There is this relationship. And things that are further away from us are moving faster away from us than things that are closer to us. It's just the way it works, I guess. And we measure this by the redshift of the stars. The light that we get from these stars is shifted towards the red end of the spectrum. And we can tell this based on atomic absorption spectra, because they have definite patterns. And so we can see this is shifted over to the red end. And that tells us this star is moving away from us at this whatever rate. And that tells us then, based on Hubble's law, that that's how far it is. Now, there are some issues with Hubble's law. There are some objects that emit light that don't seem to obey it. They're closer than their redshift would say. But it seems to hold true, and there's definitely not enough room in a universe the size 6,000 to 10,000 light years across to hold as many stars as we see that are out there. I mean, there's galaxies and groups of galaxies that we call clusters, and then there's groups of clusters that we call superclusters, and there's a lot of stars out there. Right? So let's move on. Mature creation theory. This is a very popular idea, and I think it's definitely it has a lot of merit to it. The idea is that the light was created in transit, that when God created the sun, moon, and the stars, we didn't have to wait for the light to get here to see it. The light was actually created along with the stars and the sun and the moon. The sun, it's actually not that, it's 93 million miles from here. That's not that far, comparatively speaking. It takes light from the sun about 10 minutes to get here. Okay? But at the beginning, day 4, when God created the sun, moon, and the stars, I don't think he had to wait around 10 minutes for the light to get to the earth. So I think this is part of the answer, but I don't think that we can use this fully as the whole answer to the question of how did the light from distant stars get here. And the reason is this last statement there, supernova 1987A, very creatively named. It was a supernova that was found in 1987. Yeah. But the problem with this is they observed this supernova in 1987. So a star exploded. The light traveled to Earth, and we witnessed it in 1987. Okay? If the explosion, the supernova, was seen in 1987, and the star is in the Large Magellanic Cloud, which is 200,000 light years away, the explosion happened 200,000 years before 1987. Well, that's before God created the stars, if the universe is only thousands of years old. So that's a problem. when I was first presented with that problem to this idea, I said, well, supernovas, it's just God's fireworks show. He just put a few explosions in there just for fun. He's God, he can do that. But there's an issue with that because it's not just a lights show. The stars are definitely, beautiful, and that's part of what shows God's handiwork and shows the power of God. But they're actually there. There's something there that does exist. And when there's a supernova, it also exists. There was an explosion, and there are remnants of that explosion. And so to me, that kind of crosses the border of God creating a mature creation and God being deceptive. And the God that I read of in the Bible is not deceptive. And so I'm just a little uneasy with it because of that. Now, it's necessary to have this view for certain parts of creation. When God planted the garden in Eden, he didn't plant seeds. He planted trees. It tells us that. So that's not being deceptive. When God made the Garden of Eden, there were rivers flowing out of it. God didn't have to wait for them to carve out the banks of the river. They were there. When God created Adam and Eve, they were full-grown adults. He didn't wait for them to be weaned because they couldn't. Anyway, they weren't, and all the animals, they weren't hatching out of eggs or anything like that. They were full-grown. So we know that's the case in a lot of areas, but it just has a little bit of, at least, uneasiness for me in this area. So let's go on to the next one. We're going to tackle a couple more that I'm going to dismiss, but just to give you an idea of what's out there, that there are other possible answers. This one is sometimes called the CDK theory because the speed of light, which we abbreviate C, it says has decay, or DK. Okay. So in the 60s, Barry Setterfield presented this argument, said, it seems to me as I look at the data, the measurements of the speed of light, that it's actually slowing down, just very slightly. But the speed of light seems to have been slowing down. And he put an exponential curve to the graph and said, so if we follow that back, then at some point we have very fast speed of light. And the speed of light, the light from distant stars could have got here almost instantaneously, depending on how far back you go, and what the curve is. There's some issues though. He excluded some data that he probably shouldn't have. He was kind of cherry picking the data, Another problem is we only have so much data on the speed of light. We've only been measuring it for so long. And how can we extend that curve back in time accurately? All right. So it is interesting to note, though, that there's been some recent support to it. There's a group, back in 2008, a group called the RATE Group. They did studies. This is where that helium leak data from the zircons came from. They also looked at how you could actually change the rate of radioactive decay. And in doing that, they came up with that maybe the speed of light could change, theoretically. Because that was another problem. It wasn't just problems with the data. There's some implications, some really big implications for science that go along with if the speed of light has changed. Einstein viewed the speed of light to be the one constant in the universe other than God. He seems to have believed in God. I'm not sure that he got it all right. But that he viewed of all of these stuff in the universe that the speed of light was a constant. I'm not sure about that. I think God is maybe the only constant, and he's not really in the universe in that sense. Anyway, okay, we can talk about that over lunch. So it's interesting that some creationists have come back to it and said, well, maybe it might have some merit. We still don't really have the data to support it, but maybe we can look at it more later. And also some evolutionists have come and said, we need the speed of light to change. Because there's a problem with the Big Bang Theory. And it's called the horizon problem, and the basic idea is that there's not enough, basically, there's not enough smoothness in the universe. But the background radiation that's supposed to be an evidence of the Big Bang is very smooth. There's a lot of lumps in the universe. Okay? The universe is kind of like lumpy oatmeal. It's got, I mentioned before, galaxies, galaxy clusters, things like that. There's lumps in the universe. Background radiation that we see is very smooth. That's a problem. And also in the amount of time that the Big Bang suggests, there should have been more heat exchange. There should be a smoother energy around the universe, which there isn't. It's kind of pocketed. So if the speed of light was faster in the past, that helps them with that problem. Not saying the Big Bang's right, but it's interesting. Okay, let's move on to the next one. This one's a little weird, as if the other ones weren't. So the idea here is that light takes a different pathway in space. Any Star Trek fans out there? Oh, I was kind of counting on reading that budget. That's all right. Same thing happened to me in my class yesterday. So Star Trek, I'm going to use it as an example anyway. You have warp travel, right? They bend space and they can travel faster than the speed of light. Okay? That's kind of the idea here. Not exactly the same, but it's kind of it. The light travels a different path. They talk about Rhymedian space, and there's really difficult, as I mentioned, difficult mathematical constructs. Now understand, I was reading about this mainly when I was 13, so I totally didn't understand it. And I've gone back and looked at it, and I still don't understand it. But that's, just because it's complex doesn't mean it can't be the answer. But there is another issue to this, and that's mentioned there in the last statement. The light that we observe seems to have traveled farther than this theory would suggest. How do you know that light has traveled farther? I don't know. But I'm told that there's things that you can see. It's affected by gravity and other things that it goes by, and we can somehow detect that in the light that we see. Okay, who knew? Next one, we're going to talk about sorry, that title didn't come in very clearly. It's because it's actually a link to a video, which I'm not going to use right now, because it would be internet, and that's kind of unreliable up here. But I tell you what, I will leave this PowerPoint with somebody at the church, and if any of you are interested in, there's a couple of links actually to videos in here that would give you more information about some of the topics that I'm talking about. So anyway, Humphrey's white pole theory is, as far as an answer to this distant starlight question, it's based on theories of time dilation. So there's two things that can actually change the passage of time. And it's not sitting in a room hearing somebody talk about science, although some of my students seem to think so. No, that doesn't alter the passage of time. There's two things that can slow time: speed and gravity. If you're going really fast, time passes really slowly. Now, here's the difference between that and time passing really slowly when you're in boring class sessions. Okay? When you're in a boring class session and time passes really slowly, you notice it. If you're going really fast and time passes really slowly, you don't notice it, because to you, everything's happening normally. Okay? It's just that to somebody else who's not traveling the same speed as you, time is moving faster, and so they are aging more than you. Their processes are going on faster than yours, and so on. So theoretically, if you could travel near the speed of light for, I don't know, a long period of time, you would outlive everybody on Earth, because time would move more slowly. Same thing if you managed to put yourself into some immense gravity well. a black hole or something like that. You can live forever in the center of a black hole. Maybe not, but that's the idea that a strong gravitational field warps space, and therefore time is actually stretched out, is slowed down. But you wouldn't notice it until you came back and found that all your friends were married, had kids, probably had their funerals, and you're looking at their great-great-grandkids, or something like that. I don't know. Okay. So, but that's the idea. And this has actually been experimentally demonstrated, that gravity affects the passage of time. There's atomic clocks in Denver, or somewhere in Colorado, about a mile high, mile elevation, and at sea level. And they actually run differently to one another. Okay. About 2 nanoseconds per year, so it doesn't really make a difference. But it's measurable, it's a difference, and it's because of the gravitational field. Now if you think about it, if the universe has an edge, and by the way, Big Bang theorists say the universe doesn't have an edge, okay? But it's just an assumption, because nobody's been there to find out. So Humphrey's white hole theory assumes that the universe does have an edge. If the universe has an edge, then it has a center of gravity. And near that center of gravity, time will move more slowly. And so it could be that only thousands of years have passed since the beginning of the universe from an Earth time standpoint, but possibly billions of years have passed for things at the edge of the universe. Also has to do with the expansion of the universe and things like that, but that's the basic idea, and I'm going to leave it at that for now. Okay. Third major objection to a young Earth is the fossil record. One of the things, the one that I'm going to address, is the order in the fossil record. Also just the vast number of fossils. A lot of evolutionists will say, well, that you can't have that in the thousands of years that you're talking about. I think when you flood the entire world, you can get a lot of fossils. Okay? So, and if you look at the layering, this is something I'm not going to go into a lot, but if you look at the layering, the sedimentary layers, they look like they've been laid down rapidly. Maybe they weren't. Okay, so there is definitely an order in the fossil record. Okay? I'm going to say creationists have at least 2 disagreements with the major interpretation of the geologic column. Right? One of them is the dates. We've talked about that. That's those radiometric dating methods and the index fossils. We think that maybe radioactive decay has been sped up at some point in the past. There's discrepancies anyway, so we don't agree with the way they date the bits and pieces of the fossil record. The other is that while there's definitely a time sequence locally in a set of deposits, I'm not sure that that always extends globally. And also, rather than just a time sequence in the geologic column, it may be more local environments. It may be more of an ecological distinction rather than a time distinction. So there's 3 things. Go ahead and go on to the next slide. Definite overall order. When you look at the fossil record, you can see the simple, small stuff at the bottom. You see the complex, big stuff at the top. And you go, huh, that matches evolution. When you look deeper, it doesn't match it quite as well. And I would say there's 3 factors that a creationist can say combine to give that order to the fossil record. Let's take a look at it. Next slide. One is hydrodynamic sorting. You take a bucket, fill it with water, put some sand and some gravel and stuff like that in it, shake it up. Eventually, smaller stuff that's more dense is going to settle out towards the bottom, and it's going to somewhat grade up towards the top. Right? When things get buried in a cataclysmic flood, they are going to some extent, sort themselves out that way. Now, there's other factors. So this doesn't totally explain the whole order in the geologic column. Next slide. This is another piece, differential escapability. This is probably the one that the evolutionists have ridiculed the most, drawing pictures of trees running away from the flood and things like that. But again, it's because you can't take any one of these and say it explains all of the order in the fossil record. You have to take them as a whole and say, maybe that might work. Okay? So the idea is that some things are more able to escape the flood than others. It kind of helps with explaining the order, of the animals, right? The bigger, more complex animals, including humans, would be able to escape the floodwaters more and longer, and so they'd be buried last and not fossilized. That's why we don't find, as far as I know, any pre-flood human fossils, any fossils of humans in what I believe to be the flood section of the geologic column. All the fossils of humans are in the post-flood section. By the way, there's not a lot of there are some disagreements, let me just put it that way, among creationists as to where exactly those boundaries are. But it's okay, it's science. We have disagreements, and we're still friends. So, last one. Next slide. Ecological zonation. And I think this is the biggest chunk. It's what I alluded to before. That when you look at, instead of looking at things as a time sequence, which is ingrained in us when we look at the geologic column, if you look at it, just looking at the period and you say, yeah, this is a marine ecosystem. And this is a coastal ecosystem. And this is a terrestrial ecosystem. And every once in a while you get some mixing, like that belemnite and the wood. But for the most part, things tend to get buried where they die. Well, in the flood, they don't get buried where they died. They get buried where they lived or nearby, because they might have been washed a little way away. But that's what happens. You get these pictures of these ecosystems. Now they're in a cataclysm because they're all getting buried within minutes, but there it is. Okay, that's the end of my talk about the old Earth evidences. Let's take a look at some more evidences. These are the same type of evidences. All of the evidences that we're looking at are saying, here's a process that's been going on for some period of time. Let's see how long it's been going. Okay? Based on, this is what it was in the beginning, this is what it is now, how much time does it take to get from here to here? Let's take a look at a few more of those. Go ahead and, let's see. Go back now. There we go, perfect. Okay, so fossils. There are fossils, we were talking about the fossil record, there's a bunch of fossils that absolutely show that they were buried rapidly. Fish in the middle of their lunch. They got buried while they were eating this other fish. There's even a mother ichthyosaur that's giving birth encapsulated in the fossil. Yeah. It happened quickly. All the clam fossils, all the bivalve fossils that we find, well, not all bivalves, but all of the mollusk fossils that we find are closed shell. That means they were buried alive. And if they weren't buried alive quickly, they would have dug their way out. Again, buried rapidly. I mentioned not all bivalves. There is another class of bivalves that shows that they were buried alive as well. Because clam shells, when clams die, they open their shells. Because the muscle is holding it shut. And so when they die, it opens. So that means a clam buried alive is going to have a closed shell. Brachiopods, another type of bivalve, they have a muscle that holds the shell open. So when they die, the shell closes. They're always found open shell. Buried alive. Well, there's a lot of other examples I can give for rapid burial, but it's all through the fossil record, and I'll give you one more. Polystrate trees. Okay, two more. A whale and gnon. Okay, both of those are kind of the same idea. You've got these tree fossils that extend through millions of years worth of strata, according to the evolutionists. You've got a whale that's buried nose down, tail flukes up, or is he? Yeah, I think he's down that way. Again, through millions of years of strata. The whale died, bounced on his nose, and gradually got buried over the next millions of years. I don't think so. Okay. So, coal has actually been formed in laboratories in a matter of weeks. Anywhere from 4 to 36 weeks, depending on the variables that they put in there. The continents are eroded at a rate at which they'd be gone by now if the Earth was as old as evolution says it is. Go ahead and bring the picture in now. We mentioned the helium in the rocks before with the zircon crystals. There's too much helium there. It should have leaked out. There should be more in the atmosphere. There's a rate at which it's leaking from the rocks to the atmosphere, and there's a rate at which it's leaking from the atmosphere into space. It's accumulating. We're getting more and more helium. Eventually, we should all have voices like Mickey Mouse. All of the helium that's in the atmosphere today, based on the rates, could have accumulated in 2 million years. So why isn't there more? It's a good question. Maybe the Earth isn't as old as they say it is. A few more. I'm rapidly running out of time, but stalactites and stalagmites actually have been shown to form rapidly. Opals have been formed in about 3 months, so don't take as long as was once thought. Petrification, that's in the bottom right corner there, that's a petrified bowler hat. It does not take millions of years to petrify things, unless you think that what happened in the Meet the Robinsons movie was accurate. Bowler hat guy on the back. Okay, no. They didn't have bowler hats millions of years ago. Okay, so that says it doesn't take very long for things to petrify. Not enough salt in the ocean, not enough mud in the ocean. Basically, same kind of deal. You measure the salt there. What's the rate at which it gets in there? Going back to distilled water, would take, in some cases, depending on what mineral you're measuring, only hundreds of years. Oh wait, something's really wrong there. That's even too young for a young Earth creationist. Okay. All right, moving on. A few more. Go ahead and go to the next slide. I want to take a little bit more time on the Earth's magnetic field. The Earth's magnetic field is decaying at a rate of about 5% per century. We probably won't notice it in our lifetime, but that's what it is. At this rate, the Earth can't be older than about 10,000 years. That's actually one of the reasons why most creationists will say somewhere between 6,000 and 10,000 years is the age of the Earth. They look at things like this and say, well, if that's true, it can't be older than this. If the Bible's true, it can't be younger than 6,000. Anyway, the evolutionist explanation is that in the past there have been field reversals, and we see evidence of field reversals that at some point the North Pole was actually the South Pole, and the South Pole was the North Pole. And we see evidence of that in magnetic minerals in rocks. Creationists think that those happen more rapidly and more recently than evolutionists do. And the problem with that being an evolutionary explanation for it is that field reversals would tend to weaken the field and hasten the field rather than strengthen the field and make it longer time. Let's move on to the next one. This is actually one of my favorites. Oh, nope, sorry. I forgot that this one was in there. The receding rate of the moon is going away from us, and eventually it'll float off into space. It won't happen in our lifetime, nor probably won't happen ever, because I think Christ is going to come back before it ever happens. But the point is, there's a limit to how close the moon can be to us. And that limit is too short a time for evolution. Let's move on to the next one, which is, as I said, the next one's my favorite, human population growth. You can't, well, yes you can. I was going to say, you can't argue with numbers. A lot of people do. But this just doesn't work for evolution. Let's take a look. Current Earth population, I checked it earlier this week, just counting them out. the U.S. Census Bureau has a world population clock based on census data, so that's where I got that number. We're just over 7 billion. Starting with 2 people, annual 2% growth rate, it only takes just over 1,100 years to get to our current population from Adam and Eve. In other words, it's not a problem that the population is so big. We could definitely have come from 2 people. At the 2012 estimated growth rate, it only takes just over 2,000 years. Right? Why did it take so long? Wars, famines, pestilences, right? Cuts it down and stretches it out. Okay. If you want the evolutionary age of man, which is somewhere around 1.5 million years, you have to take the growth rate down to 0.00147. Wow. That's too small. I think, did I put one more in there? Yeah, one more. For 4,500 years, right, that's the time since the flood, with an initial 3 couples, 6 people, because as far as we know, Noah and his wife didn't have any kids after Shem, Ham, and Japheth. The rate's a lot closer to something reasonable. It's still low, but again, that's because there's been a lot of wars and famines and things like that since then. Okay, let me wrap up, because I just went over an hour. So which one's right? We look at evidences for an old earth, we look at evidences for a new earth, and we say, which are we going to trust? Well, first let me point out that these methods essentially give maximum ages. So the shorter ones are more accurate. I did mention that some of them are too short. So that means none of them is absolutely true. And here's the thing. All the evidence that we've looked at is circumstantial evidence. Because it's based on these methods, we don't know if the rates have been the same throughout time, all of this kind of thing. There's another type of evidence that they use in courts, right? You've got circumstantial evidence, and you have eyewitness accounts. We have an eyewitness account. Or at least something that claims to be, and I think it's pretty good. When we looked at it, and we did. The Bible says that the earth is young. And I think since it's debatable based on the circumstantial evidence, let's take the eyewitness account and say that the stuff that agrees with that is probably pretty good. Last thing, next slide. I just wanted to give a little bit of, it's a little overview of what does the unearthed creation model say is the history of the world. It's summed up in the 7 C's. I borrowed it from Answers in Genesis. There we go. It just doesn't like that slide. That's all right. I can sum it up. The 7 C's, we have creation, the actual creation week. Corruption, the fall of man, recorded in Genesis chapter 3. It's very important that we understand that, because that's kind of the answer to the question of, if God is good and God is all-powerful, then why is the world so messed up? We messed it up in chapter 3 of Genesis, and we've been messing it up ever since. Okay? So creation, corruption, catastrophe, the flood. This is the reason why we see the fossil record and why we have some of the geologic features that we have around the world in such a short period of time. Creation, corruption, catastrophe, confusion, Tower of Babel. Did you know evolution doesn't really have a good answer for why there's so many language groups? Not just languages that could have derived from one another, but language groups that don't show any connection to one another. But the Tower of Babel explains that. So, creation, corruption, catastrophe, confusion, Christ. God came to earth and stepped into history and decided to be born as a little baby. That humility that we talked about before was shown right there. All that power and authority in a little baby. Creation, corruption, catastrophe, confusion, Christ, the cross. The central focal point of all history. Not only did God come down and become a man, but he humbled himself further, died on the cross because we needed that. This is the gospel message. The gospel message is there in history. God created us to have that fellowship with us. We messed it up. That's the corruption, confusion, catastrophe. When we sin, it leads to catastrophe and confusion in our lives. But God stepped into history, died for us, paid the penalty for that corruption, catastrophe, and confusion. And then we have hope for the future. That's what consummation is about. It's when Jesus comes back and we all go to heaven. What a day of rejoicing that will be to our life in the Lord. Let me pray for us. And you can go ahead and go to the next slide. It is just some contact information for me. Like I said, I will go ahead and leave this PowerPoint so that it'll be available to anybody that wants it. And feel free to contact me. I have business cards if anybody wants that to give contact info for me. If I don't get to talk with you personally and answer your questions today, then definitely feel free to email me or call me, and I will try. Let me pray for us. Lord God, we thank you so much for your creativity, for your power, for your authority, for all that you have done for us, for your sacrifice on the cross. And Lord, we thank you for this opportunity that we have had to look at your creation and to look at who you are. We just pray that you would guide and direct through this retreat, that we would all come away from this encouraged and closer to you and ready to do. It's in your Son's name that we pray.